minus work function. So this will be SA will be 124 electron volt nanometer. This is nanometer. And there's a very standard thing and work function of this we know 2.2 electron volt. So we'll get K max in terms of electron volt. Anybody value? 124 by 124 by 35. Anybody value?
3.54, sir.
Yeah, okay, 3.54 electron volt. Okay, this much is there. Okay, look at the polarity now. So what this electric field will be acting in this direction. Finish. So the moment you connect a cell, you bring this into the picture. So what that electrostatic field will do, will decrease the kinetic energy of the ejected particle, ejected photoelectron. Okay, now let's get into the problem. The sliding contact. Okay, this is about the 10 volt is telling.
That is not 3.54, sir.
Not 3.54. Huh?
It's 1.34.
1.34.
That particular
K max is that much, it means. Okay, 1.34.
1.37, sir.
1.34, sir.
4 only, sir.
4 only. Okay, we'll keep this much.
4, sir.
Okay, no. Okay, there's a K max. Now, first, when it is at A, it's telling find the reading of emitter when the slider is moved to the end A of the wire. When slider is moved to end A of the wire, there won't be resistance by the rheostat. So what all the 10 volt applied will, will appear here. So the reading of emitter, when the reading of emitter will be there when the electrons pass through it. A simple diagram. $10 volt is applied. Here it is ejected with K max. The electrostatic field will be like this. So it will experience a force. Okay, now let's calculate what is the speed of electron when it reaches here. K. Okay, now initial kinetic energy K max plus work done by cells should be negative, no? So therefore E into this will write V naught equal to K. So K max is how much? 1.34 electron volt. This is how much? 10 electron volt. So what do you expect K? K will be some sort of negative. So will be 8.3466. Yeah. Negative means not possible, no? The electron cannot reach plate C, cathode. So negative sign. Therefore, electron cannot reach the cathode. Photoelectron. Ejected photoelectron cannot reach the cathode. So therefore, what should be the current? So will be 0. So shall we add up? Therefore, the maximum kinetic energy electron itself is unable to reach. So what about other things? Definitely. So what happened will be 0. No current flow will flow through the emitter. Okay, fine. So this is the condition. Just she has brought some idea, nothing else there. No, the slider is moved gradually away from A. Plot the variation of emitter current reading versus distance of the slider measured from A. I'm going to slide it away from it. Okay, when do current will start flowing? When do electron will reach? The first thing is when do the electron is capable of reaching it here. Just even if it just reaches also, I think when potential difference is 1.3 volt. drop across, this is 1.3 volt. The 10 volt, this will be 10 volt. So here what is telling is, this is like a potential divider you can take. This will be 10 volt only. I can't change this one. So as I move this, so here how much, when jockey is here, how much here 10 volt it will drop here. So now as I start moving, then a current will flow. So when do what will happen? When the drop across this becomes equal to 1.3 volt, then only current will flow no here. So now you can ask questions, sir, no current here, then how come drop? The drop can be from here. This is very important. Please do look at here. There'll be flow of current. There'll be always continuously flow of current. I'll have to indicate something like this, I dash. This I dash will be non-zero wherever may be the jockey, either at A or B. Well, if you can agree this, I think it will be a very easy thing. Just observation of the problem, nothing is there. Yeah, fine. Now, when the jockey is at A, what is the drop? The old 10 volt will drop here. No, as I start moving it, we know what is the current here. So now as I start moving, there'll be some drop. So what all the applied EMF, a part will drop here, a part has to be dropped here. This will become like a potential divider formula. When the electrons will start reaching the collector, only when the potential drop across this is less than or equal to 1.3 volt. 1.3 volt here means 8.7 should be here. So when do the reading of current will be non-zero? When the jockey is at a distance of 87 centimeter. I think I'll better, instead of shouting so much, let me draw the diagram. Diagram. Okay, let me copy this. There's a very good problem. It's the small idea of potentiometer is what is trying to introduce here, nothing big. You can expect in exams of this kind. Okay, I have brought it everything. So here, let me indicate the distance x. There'll be a flow of current I dash. The drop across this, you write it, drop across the tube, I'll write. Shall I write VT? So what all this 10 volt, what we apply, a part of it will be shared by this, remaining will go potential divider formula. So when do the electrons will come and strike the cathode? Only when potential difference becomes less than or equal to 1.3 volt. So now this is how much is there, 10 volt and 100 centimeter is there. Here 10 volt is there, 1.3 volt, if it drops here, remaining how much will be? 8.7 volt. And look at the slider resistance, 100 centimeter, 10 ohm. So how much of length it should be? X, 87 centimeter. So when the jockey is at a distance of 87 centimeter, then what will happen? The electron starts reaching the cathode. Reason for that, the idea here. Able to understand? So there's some potential divider concept is what I have brought it. So this 10 volt, okay, for option B, I'll bring it. 10 volt should be equal to VAJ plus VT. When the electrons will start striking the cathode, the electrons photoelectrons, okay, yeah. The photo reach the cathode C only when VT is less than or equal to 1.3 volt. Okay, so therefore, what should be the value of X? X should be 87 centimeter. Will you agree this? So is it justified? He's asking no. No. When X is greater than 87 centimeters, so what do you expect? The drop across the cell will be less than 1.3 volt. So then more electrons will come and strike the cathode. So what do you expect? The current will increase. He's asking to plot the graph. Somewhere this is 87. The curve, anybody how the curve should be?
Initially zero na sir. So it will be a straight line.
Initially it'll be a straight line, horizontal.
Also it will be linear.
Linear, no?
Sir.
No, okay, this one here. Finally, when it is at B, when it is at B, what will happen? We'll get a maximum current. Okay, that has to be. So any information if we have.
Why is it linear, sir?
Some of you said linear, I wrote linear.
It will increase, but we don't know if it will increase linearly or not.
Mm-hmm. Okay, the expression for current, no, this is the current. How the graph will be?
Some sort of concave up, sir, because when the length x is 87 centimeters, only the electrons which are ejected with maximum velocity can reach C, and the number of such electrons is less. But when x is equal to 100, then all the electrons can reach C. So the total number will be more. It should be some kind of concave up.
Should be increasing one.
Yes, sir. Slope increasing.
Increasing slope. Huh?
It should be something with increasing slope, but we cannot tell exactly what.
Curve like this. Huh?
Yes, sir.
Okay, that one. Oh, that cloud also we should take into picture, no? So how many will come and strike?
Number of electrons. That is why the slope is increasing.
And afterwards it remain constant, no? Whatever we do. Once it reaches B. Okay, I'm not very sure. Like, okay, it should be increasing. It should not be linear. Okay, fine. No. Yeah. Okay, there's a but curve. Okay, any specific reason? Okay, regarding cloud, we don't know, no? How many electrons they come and strike.
So why increasing slope, sir?
Sir, if we take the amount of electrons, like quantum efficiency, generally we get quantum efficiency as 1% or something. So there are very few electrons which are coming out with maximum kinetic energy. So when the potential difference is just enough to make them reach C, there are very few electrons which are going. So current will be small. But as soon as I reduce the potential little bit, there are more number of electrons which are having lesser kinetic energy.
Okay, so it's something, why the curve should be like this only? Because here cloud will be there. So here what happen as I start moving it, oh, this will start decreasing it, no? As I further increase, the drop across this will decrease. Okay, still the E is like this, no?
Sir, can we say something that as ejected electrons, uh, the number of electrons having more kinetic energy is less? Like if we consider kinetic energy and number of electrons, as kinetic energy increases, number of electrons decreases. Can we accept that, sir?
No, yes, like this particular thing will keep on decreases here. As it keeps on decreases, then what happen? The number of electrons striking what happen will increase. Kmax, only Kmax one. Kmax one, and other than Kmax also will start moving and they'll strike this one. Okay, the zero, the cloud one will never come here, no?
Cloud will also come, sir. Accelerating electrons. Yeah, okay, sorry. Cloud will not come.
Cloud will never come. Huh? That's the thing. The cloud will never come. The cloud here will never move. The space charge layer will never move. So and along with Kmax now, suppose a Kmax is able to come along with Kmax, the other things also start moving. Okay, we don't have any exact.
As we decrease the potential, more and more number of electrons start hitting the plate C in one.
Okay, that's yeah, increasing. I know it, but curve why only like this? Huh? It should not be linear also. That much we are okay. We can see.
Initially, fewer number of electrons are hitting it.
Yeah.
And as I decrease the potentials, the number of electrons which are having greater kinetic energy, that will increase. That is why I told increasing slopes.
No, di by dx is what the graph is what we are trying to justify here.
Suppose maximum kinetic energy ejected is 1 electron volt, sir. So if we consider some 1,000 electrons, out of that only few, like 5 or 10 will have K max. Then more number of electrons, 20, suppose 20 electrons will have little less than K max, something like that. So considering that, I told, sir. Because number of electrons having more kinetic energy is less.
That will Kmax will their number will be less. Okay,
That
with
is
the
why increasing slopes.
as VT decreases, what happen along with Kmax, other electrons also will start coming and striking cathode.
As I decrease VT more, their rate will also increase. That is why current will increase exponentially.
Current will increase.
Why rate will increase, sir?
It should increase, no? Because along with Kmax, the electrons with less Kmax also will come and strike cathode.
How can you say the rate will increase or it will not?
Very simple. See, like if only Kmax is able to reach. Afterwards, what happens as VT decreases, along with Kmax, the less Kmax also will increase. No, electrons with less kinetic energy also will strike cathode.
Sir, how can you say that di by dx is greater than 0? The slope is always increasing.
See, the amount of electron striking that will increase, no? So current will
Sir,
increase. Yeah.
current will increase, sir. How can you say that the slope is increasing?
Because see,
Particular graph.
the number, suppose say there are 100 particles are there, Kmax there are 10 are there. Okay, then which are between say like a less than Kmax there are 30 are there. So that 30 what happen will start increasing, will come and strike, no? Cloud will never move. Cloud will never move. So along with Kmax, K will also increase here. So you mean to say how that dy by dx, why not constant, why not curve, that you mean to say, no? The rate at which they are striking, okay, this x is a, say one thing we are very sure, the number of electrons striking cathode is not fixed here. Its number will keep on increase. So therefore I should go for a curve, not a straight line. That much I'm very particular. Okay, this is about now find the maximum speed.
In
Which
X-rays, we have a graph now, sir. Plot against saturation current and voltage.
Yes, sir. X-rays graph we can use it.
That graph will come now, sir, like convex up. The decreasing slope. Decreasing slope and then it become constant.
constant.
Yes, sir, obviously
Sir,
constant will
but
become.
not
Oh,
in this case because potential difference is in other direction. If we change the polarity, then we can get eye saturation.
so saturation will be there on the other side, no? That's what like.
The graph increasing slope will not come now, sir.
No, this will be like as x increases, VT will decrease. Then there's more more possibility of more electrons coming and striking the cathode. No, the number will increase. No,
Number will increase, sir, but what about the rate, sir?
the rate definitely will be different.
Number should be same, sir. Rate will increase.
Yeah, that one, it should change.
Because anything k greater than 0, it will eventually come and strike C when Vt is 0.
Because as Vt decreases, more and more electrons will come and strike it. The rate should not be uniform. That much we are very sure. I can say the rate should not be uniform. With this, if not vertical line, it should be some sort. We'll go for a curve.
That's I'm saying slope should decrease, same as the X-ray graph. In X-rays, we have one graph, na sir, a plot against current and stopping potential. That will have a decreasing slope. Same kind of graph will get, na sir.
Yeah, it's not a. Okay, you mean to, but it is a. Stopping potential effect will come only here, no? Afterward, there's a retarding potential. What we get it.
No, sir.
So yeah, after this, what happened? They don't have energy to reach that particular thing. After this, they'll start reaching. Okay, anyway, I'll just think over it, the exact curve. Okay, I'll put question mark. Anybody wants to, if you can go further. Find the maximum speed with which an electron will hit the collector plate if the slider J is placed at a distance of 95 centimeter from A. Okay, 95 centimeter means 0.5 volt will be there. So K max minus 0.5 electron volt, I'll subtract the option C. Okay, 1.3 electron volt minus 0.5 electron volt. How much it was? 1.34, no? Yeah. Anybody just value? .78. Just give me value. Well,
0.84.
0.84. Yeah.